Hello again, and welcome to Configuring Charts. We've learned a lot about visualization so far, but there's a lot we still haven't covered. In this video, I'm going to try and take you through some of those topics. For example, we're going to look at calculated metrics, we're going to look at how to change colors and configure the visual appearance of your chart, and we're going to take a look at some more esoteric visualizations and some of the more powerful ones like the pivot table. Let's get started. So I'm just going to jump into our Zoom data instance. Remember this flight delays dashboard we had from the dashboarding video? We're going to leave that for now, and instead we're going to create a whole new dashboard. So I'm going to use this button method. Remember, you can also create a new dashboard through the hamburger menu. We're going to make it with the flight delays CSV file. And now I'm going to make a multimetric line chart for this one. Great. Now, if you look through, we have departure delay and we have arrival delay, but the data we got from the FAA also includes a whole lot of other delay types. For example, late aircraft delay, security delay, weather delay, airline delay, and air system delay. These 5 delays together create the arrival and departure delays that that the FAA lists under all of these. However, not all of the aircraft have this breakdown, so there are slight inaccuracies with the sum of all of these and the arrival and departure delay. Now, what we're going to do today is we're going to look at this and say, well, what if we didn't actually have arrival and departure delay? What if we just had this data? How would we come up with departure delay? Well, obviously, you could go into your database and you could write a script that queries all of that, adds it as a new column. You could create some sort of view that does that. But you can also do it in Zoom data using calculated metrics. And that's what we're going to do now. So to create a calculated metric, you go to your metric picker, scroll down to the bottom, and hit Add Calculation. This will open up the calculations editor, and this is where you can create calculated metrics. Now, on the left pane here, you see some functions, and if you click it, it'll paste it in, which can be very helpful. And what we want to do right now, though, is we want to add all of these 5 sub-delays. So air system delay, we want airline delay, we want late aircraft delay, security delay, as well as weather delay. So now you have all 5 of these, right? So let's just add them. And you might think that adding all 5 of these will give us the total delay, but it actually won't. See, if we run this calculation, it'll error because the formula doesn't contain a valid aggregation function. So when you're thinking about this, understand that what's happening here is you're adding the air system delay to these airline delays. You're not adding numbers, you're adding the actual fields. So to actually add the total air system delay to the total airline delay, you need to add an aggregation function, and we're going to be using sum for ours. So I'm just going to paste in the sum function here, and we're just going to wrap all of each of these in a sum. And then the addition should work fine. So now, once all of these guys are wrapped in a sum function, now you're adding numbers. You're adding aggregate numbers. And now when we run this calculation, it should give us a table. And you can use this table to kind of validate this information. For example, if we set it by origin airport, we should see that the total delay, for example, for O'Hare should be higher than for IAD. And that's true. So it looks like that's about right. So seeing that this works fairly well, we're going to name our calculation. Let's call it total delay. And we'll save it. And now we can close this. And instead of selecting all 5 of these, we can select our new formula, total delay. And while we're at it, let's deselect all of these guys. And let's select departure delay just to see how close of a fit that is. And we want the sum, the total departure delay, because this is also total delay. And you can see there's definitely some inconsistency here, but in general, it's a pretty good fit. And if this spiky graph's not very aesthetically pleasing, that's because it's set by day. You can set it by week or month and get a little more of a readable graph. Okay, so now we have total delay, and this can be pretty useful, especially if we didn't have departure delay with the FAA data and had to add it on our own. Next, I want to show you one of my personal favorite chart styles, but before we do that, don't you think that this yellow and blue color scheme is getting a little exhausting after building like a dashboard with it? We can change the colors of these lines fairly easily using this color button here on the left rail. When you click that, you have a couple settings. It'll show you what your colors are. You can enable and disable the legend. This might be really useful if you don't need it or if you want to roll over it just to get that information. The other thing we can do is change the colors. So you do that by clicking this color settings. And we have a bunch of color palettes already preloaded into Zoom Data. These come from Cynthia Brewer's Color Brewer project, and a lot of these color palettes are very good. They're great for data viz, they're balanced for luminosity and spectral energy, and many of them are colorblind friendly. Now, if you want, however, your own color palettes, for example, if you're working with a client and you want your reports colors to match their branding, you can click, instead of automatic, assigned colors. And then you can assign your own colors using this color picker. You can even enter a hex code. So let's say FA3CD2. I put a V in there for some reason. It's not a hex code. There we go. And we have like this hot magenta. And we can put a cyan here. There you go. And so that's how you change the colors of lines or any kind of diverging series. So next I want to show you one of my personal favorite graphs, and that is the packed bubbles chart style. So I'm going to click packed bubbles, and this is going to maintain a lot of the same information. For example, the group is still grouping by time. Now, what I want to convey with this right now is packed bubbles is especially good at showing numerical data in a visual sense. And so I'm going to group by airline, and total delay is fine. So this is really cool because if you say had like 100 airlines, like the full data set of this has, you can use this to kind of see which airlines in a very visual sense are contributing or have the highest total delay, because it'll just pop up and it'll visually bubble up. And this can be really, really helpful when you're dealing with attributes that have really high cardinality and you want to just see what types of data bubbles up. That's part of the reason I really like packed bubbles. Now, you can see the biggest offenders in total delay are American, United, and Delta. But that doesn't really make that much sense, because what it is that their total delay is very high because their total volume of flights is also very high. So what we really want here is average delay. So let's create another calculated metric for average delay so you can see how that works. To do that, I could either edit this, but what I'm actually going to do is duplicate it and edit the duplicate so that we can keep total delay as well. Let's rename the duplicate to average delay. And so if you guys remember, the average is the total divided by the number of things being averaged, in this case the number of flights, and in our case it's just count of all. So now we save this. Actually, first let's run the calculation to make sure that everything is as it should be, and so far it looks good. And let's look at like different flight numbers, for example. So like these flights, I guess these were all canceled flights, or they didn't have these sub delays. So let's look at destination airport. Okay, that looks about right. So once we've validated that it looks like our metric looks accurate, we can save it, close it, and then we can look at average delay to see what the worst offenders for average delay are. Okay. And I'm also going to color the bubbles by average delay so that it's a little more consistent. Great. So we can see that Frontier, Spirit, a lot of these are a little more of the budget airlines. And I guess they are more delayed because of their lower budgets, I guess. So that's really interesting, and I'm sure if you guys have flown on some of these airlines, maybe not particularly surprising, but it's cool to see this show up in a visualization like packed bubbles. Another thing I want to show you is, remember how we changed the colors of those lines? You can also change the colors of these bubbles, but it's not quite the same because the lines had what's called a diverging color palette. Since each line was separate, the point of different colors was to differentiate them. But in this case, the colors are being used to convey a metric, average delay. So the ones with the high average delay are blue and the ones with the low one are yellow right now. So we actually want a gradient. And it turns out Zoom data has a bunch of wonderful gradients loaded in as well. Let's take a look at a few. And these are also from Cynthia Brewer's Color Brewer project. And we also have double-ended gradients. So if you want the lows to be red and the highs to be blue, you can do that as well. You can also set up your own color palette by clicking Color Range. And then, again, you can select the colors. Let's have like a yellow fading into a bright green. And there you go. Another thing you can do is if you click this distinct colors, instead of fading from one color to another, it'll actually just have a threshold. So if your delay is more than 15 minutes, it'll be this shade. Or if it's less than 10 minutes, it'll be that shade. So that can be helpful for bubbles with like wider ranges of data, or if you want an easier chart to read in terms of the legend. So now you kind of know how to look for colors both in divergent data sets and in metric-driven data sets. One more thing I want to show you is the pivot table. The pivot table is one of Zoom Data's most powerful and widely used visualizations. If you've ever used a pivot table in Excel, you should understand how this works. It's essentially a table that lets you do multiple group bys. And when you're looking at it like this, it seems pretty plain, but you have to click the configure button. And once you do, you can actually set up pretty interesting sets of group bys. So let's say we want to look at the average delay, and we want to look at the average delay based on airline, and also we can have it based on month. So scheduled departure, and not day, but month. Actually, it might be better to set month up here. You can just drag and drop to do that. And now we can see for all of these months, the average delay per month, and it looks like the highest is in June. You can also see the total of the average. You can also see for each month, let's say we want to see what the worst offender in February was. With 43 minutes, it's F9. I'm pretty sure that's Frontier. Let's look it up. F9 Airline. That is Frontier. Fantastic. So the pivot table can be incredibly powerful for showing you comprehensive views of data grouped by several different attributes. And you can do all sorts of things. You can add more rows. You can move your metrics from your columns into your rows. Things can get very complicated very quickly. So basically what we've done now is we have deepened our understanding of visualizations and dashboards. We've become familiar with the different types of color palettes. We've looked at the pivot table, we've looked at packed bubbles, and we've explored calculated metrics. And by the way, that's just a start. If you go to the Zoom Data knowledge base, there's actually a whole reference for calculated metrics, and there's a language definition. And if any of you guys are programmers, you'll really enjoy figuring out how to come up with really, really complex calculated metrics. And you can do that all from inside Zoom Data. No need to muck about in the underlying data source. So make sure you take a look there as well. This pretty much concludes this section, and I hope you guys learned a lot. Thank you for listening, and enjoy. Bye-bye.